This is a Faraday flashlight. It's currently uncharged, so if I switch it on, there's no light coming out of it. It's called a Faraday flashlight because it's based on Faraday's law, which is sometimes referred to as Faraday's law of electromagnetic induction. Now, what we have in here is a coil, this copper area, and there's probably about 1,000 turns on it. And there's a permanent magnet, which is on to the left of the coil right now, but if you tilt the flashlight, the magnet will slide through the coil. Okay, we know that when there's a changing magnetic field in this coil that there will be an induced current. And that induced current is in a direction to generate a magnetic field that will oppose the changing magnetic field due to the magnet sliding through here. Now there's a simple circuit, which I'll show you in a minute, that takes this current and charges a capacitor. And that capacitor acts as the power source for the flashlight. So let me charge up that capacitor. And now switch it on. Here's a schematic of our Faraday flashlight. So here's our coil, here's the sliding magnet, this is the capacitor that's going to be charged, here's our light emitting diode. And this arrangement of diodes will ensure that no matter what direction the current is flowing through the coil, the current is going to be flowing onto the top plate so that the top plate will become positively charged and the bottom plate negatively charged. So from the perspective of the magnet, if the magnet's going in, there's going to be an induced counterclockwise current in the coil so that the magnetic field, due to this induced current, opposes the increasing magnetic field from the magnet sliding in. So the current will flow this way, and this diode will block the current, this one will let it pass, so the current will flow this way and charge the top plate positively. Now when the magnet is sliding out, the field is decreasing, and so now there will be a clockwise current generated in the coil, and so the current will be flowing like this. This diode will block the current, this one will let it pass, and again positively charge the top plate. Now with the capacitor charged, we can close this switch, and that will cause the LED to turn on and light emission.